So I'm Tiéba SIMONIS. I'm currently an intern at CIRAD in Montpellier, and I'm going to present you the study I conducted in collaboration with Nawel Achir, Christian Mestres, and Léa Ollier on the relationship between yam texture changes and the behavior of starch and pectin during cooking. So currently, the majority of studies investigate yam texture in a static way, before and after cooking, without observing its dynamic evolutions during the cooking. And moreover, yam texture is generally linked immediately to starch gelatinization, which is understandable given the very high starch content of yam. But we believe that despite their low content, pectins should not be underestimated, and that the study of their behavior during cooking can provide us with very important information in the understanding of the modification of yam texture. So as a reminder, pectins are polymers of galacturonic acid found mainly in the middle lamella and in cells walls, where they are involved in cell cohesions. During heat treatments, pectins are degraded by beta elimination reactions, leading to a decrease in texture during the cooking, unlike starch, which increase texture by gelatinizing. So we hypothesized that pectin had a key role in the final texture of yam after cooking, and that once the starch was completely gelatinized, the texture evolved according to the degradation of pectins. To validate this hypothesis, we carried out different yam cooking processes with 4 cooking times: 0, 5, 10, and 15 minutes. 15 minutes being the cooking time considered as optimal for sample size. And then we proceed to texture measurement and an analysis of starch gelatinization and pectin degradation. In order to do this, we started by making a precise sampling on 2 varieties of yams with different texture. So yam from France and yam from Ghana. But sadly, we don't have any other information about their precise variety or cultivar. So we started the sampling by cutting the proximal end, and we used only the central and distal sections. That's because previous studies have shown that there are concentration gradients and therefore different physical behavior in yam tuber, with a more marked difference between the proximal end and the two others. Then we carried out our texture analysis on the samples steamed during 0, 5, 10, and 15 minutes with a conical probe penetrometer. And the result allowed us to follow the evolution of the hardness during the cooking of the yams. So first of all, we observed that despite numerous repetitions, we still had significant standard deviations. We carried out 15 repetitions per cooking time, and we believe that this is a minimum in order to obtain reliable results. It also allowed us to confirm the texture difference between the 2 varieties of yam. And it can be seen here that yams from Ghana clearly have a higher hardness than French yams. And that can be directly linked to the very different dry matter percentages. 36% for yam from Ghana and 14% for French yam. Lastly, it allowed us to observe the similar textural behavior for the 2 variety, with an increase in the hardness during the first 5 minutes of cooking, followed by an almost linear decrease. And this curve confirms the importance of carrying out a dynamic analysis and not only studying the before and after cooking. In view of these results, we wanted to determine the progress of starch gelatinization in our samples. And we therefore carried out an analysis of gelatinization by using a DSC method. And it was observed that starch of French and Ghanaian yam started to gelatinize at 65 and 69 Celsius degrees respectively. And also that the starches were completely gelatinized at 5 minutes of cooking. So for now, this was in line with our hypothesis. After that, to continue the validation of our hypothesis, we looked at the degradation of pectin. And to do so, we cooked new sample still during 0, 5, 10, and 15 minutes, and we studied the behavior of pectins during cooking. Our focus was mainly on soluble pectin, since they directly account for polymer degradation by beta elimination. Because by acting on the long chains of pectins, which are difficult to solubilize, beta elimination will release galacturonic acid monomer and short chain pectins, which will be more soluble. And by measuring them, we obtain an estimate of the degradation of pectin. So this analysis was carried out according to the method developed by Christian Mestres, Léolier, and Julien Ricci. So once cooked, the yam samples were freeze-dried and grinded into flour. And then, because of the high content in starch of the flour, we needed to extract the soluble pectin by using a specific extraction buffer, and by letting them at the optimal extraction condition, so 1 hour at 55 degrees. Then we used a continuous flow analyzer, which allows the automation of the acid hydrolysis of pectin, the contact of the liberated galacturonic acid with a specific colored reagent, and the measurement of their concentration by absorbance. To better interpret the result, we have crossed them directly with the texture measurement that I presented earlier. And for French yam, we observed an almost linear increase in the soluble pectin content. But it seems to reach a limit value at the end, but in view of the standard variation of the last measurement point, we cannot really be sure about that, and it still can be an almost linear increase. For yams from Ghana, there seems to be a direct correlation between the increase in soluble pectins that start at 5 minutes and the decrease in hardness during cooking that appears at the same time. In view of this result, it seems to us that we can validate our hypothesis and admit a correlation between the degradation of pectins and the decrease in texture. It's particularly marked for the yam from Ghana, but it can also be considered in yam from France, even if the correlation seems to be inversed in the first 5 minutes. The starch content being much higher than the pectin content, it's logical that despite the degradation of pectins, the hardness increases with the gelatinization of starch. So we found this soluble pectin trends very interesting, and in order to characterize the degradation of pectins in more details, we carried out other yam cooking experiment with the aim of determining kinetic parameter. So that time we changed our sampling and we used crushed yam in vacuum bags because we needed to get a uniform heat transfer, and we cooked them at 3 different temperatures, so 80, 90, and 100 degrees. And after, for the pectin galacturization, we used the same protocol than before, so freeze drying, grinding, and soluble pectin assessment. With the soluble pectin content we get with this new experiment, we observed that the soluble pectin seems to follow a zero-order kinetic, and by using the Arrhenius law, we achieved to determine our kinetic parameter. And this directly led us to our final work, which was to model the yam cooking by using the COMSOL modeling software to simulate a pectin degradation and starch gelatinization. So for the pectin degradation, we kept our zero-order kinetic assumption, and we used our previous result obtained with the Arrhenius law to simulate the degradation. For the modeling of starch gelatinization, we didn't conduct a new experiment as starch is a well-studied phenomenon, and we used a pre-existing model developed in 2018 by Giraldo at Qualisud, but which was for plantain banana. so we adapted it to our matrices. And so with this model, we achieved to obtain the necessary parameter for the heat transfer and for starch gelatinization equations just from the water content of the yam. And then we start our simulations. So here we can see our simulated curves with also our experimental point. And so we obtained satisfactory cooking models for the starch gelatinization and for the heat transfer, even if the core temperature is it's a little bit underestimated. But what's most important is that we really need to improve the pectin degradation modeling because for now it don't fit our experimental results. And we think that it's because we determine the pectin degradation parameters with the structured yam, while we use the whole piece of yam for the experimental point. But you can still use this model to observe the impact of sampling in yam cooking. So even if it was expected, here we can see that the sample size has a strong effect on the cooking time. The bigger the samples are, and the longer it takes to the core temperature to increase and to get a total gelatinization of the starch. So we hope that once this model will be finished, we will be able to link the starch gelatinization and the pectin degradation to the texture of yams. In conclusion, thanks to these manipulations, we were able to confirm the importance of carrying out a dynamic study of the texture and to confirm the importance of the role of pectin in the study of the texture of yam during cooking. It seems that the gelatinization of the starch occurs early in the cooking process and that the final texture can be related to the degradation of pectins. We also know the importance of repetition for texture analysis and the importance of an accurate sampling when studying cooking. And to finish with, we can note that we have obtained a relatively satisfactory model of yam cooking for the heat transfer and the starch gelatinization, but it still needs to be improved, and especially for the pectin degradation. And our final step will be to be able to directly model the evolution of texture as a function of cooking temperature, starch gelatinization, and pectin degradation. Thanks for your attention.